Okay, guys, we're going to cover 1.5, solving inequalities. The objective today, solve multiple step inequalities with one variable. Okay, before we get into solving inequalities, this is material you will see on the homework assignment for page 40 tonight. And essentially, all it is, it's some sort of lab, and it discusses this thing called interval notation. All right, with inequalities, we see things like x is greater than 2, y is less than or equal to 5, things of that nature. So when we talk about inequalities, we're talking about an infinite amount of solutions. And another way to represent these inequalities is using what we call interval notation. So if you take a look at this first example problem, we're trying to figure out, write each interval in terms of an inequality and then graph it on a number line. Well, what this means when you see two numbers like this, it almost looks like an ordered pair, but you notice the bracket by the -2, that means we're going to include. So back up here on the top right, y is less than or equal to. That little equal sign gives it a bracket. Without the equal sign, just greater than right here, x is greater than 2, we would leave it as a parenthesis. So in looking at this problem number 1, my solution set is in between. Okay, x is in between -2 and +6. So if you read them separately, it would say x is greater than or equal to -2, and at the same time, x is going to be less than +6. So on a number line, when you create it, -2 is here, 0, and +6. When you have something less than or greater than or equal to, we're going to give it a closed circle. So we put a closed circle at -2, open circle at +6, and we just connect the dots here. And we say, hey, there's my solution set for the inequality, -2, 6. Now number 2 is a little different. There's an infinity sign, and all that means is that we're going to take every number, including 4, and larger than that is part of our solution set. So we can write it like this: x is greater than or equal to +4. And remember, guys, the equal to sign is there because of the bracket. If this was a parenthesis, it would be x is greater than 4. All right? So just keep that in mind. So here we go. On a number line, it's fairly simple. We take +4, close circle because of the equal sign, and it's greater than, we are going to the right towards the positive direction. All right. Number 3. -infinity to +infinity. Notice the brackets on infinity. Oh, excuse me, that's an 8. Sorry. I do need to talk about those brackets. No, not brackets. The parentheses. Sorry, the parentheses on the infinity sign. The infinity sign, right? It's more of a concept, more or less, right? You can never ever reach infinity, so we will never bound it with a bracket. We will never include infinity because it can never be reached. So we have 8 to -infinity. So we can write it like this: x is less than +8. Open circle, +8, open circle. Okay, and we are going towards the negative direction. So this is 7, 0, ... Goes on forever in that direction. So that's what it looks like going from interval notation to the inequality itself. We could go the other direction. You could start with an inequality like this: x is greater than or equal to 3. At the same time, x is less than 9. And what that looks like, because of the equal sign, 3, 9, not included, it gets a parenthesis. And then you graph it on a number line, just like the ones before. Okay? X is greater than, number 5. X is greater than or equal to -5. We can say, bracket, -5. And because it's greater than, we're going to go +infinity. If it said less than, we would write it like this. So if I had x is less than or equal to -5, it would be parenthesis, negative infinity, because that's where we're coming from, and we will stop at -5. So it kind of looks backwards. Okay. Interval notation, you will see that all year long. So if you don't understand it right now, and after you practice it, don't worry about it. We'll talk about it Monday. But please do me a favor, do everybody else a favor, and try to dig into page 40 and understand the interval notations. Okay, so solve inequalities, just like you solve equations. Remember, the only difference is when you multiply or divide by a negative number, you must flip the inequality symbol. That's something I believe all of you remember from back in the day when you learned how to solve these inequalities. Now, if I'm looking at this example number 1, you could write it down. You could pause the video. You guys could rewind it at any point. I am going to subtract 4y both sides. Also, the notes are already on Blackboard, so if you don't feel like watching the video, you can go ahead and follow along with the notes. So I have -3. I'm going to put that over here actually. -3 less than quantity y plus 2. We'll subtract 2 both sides, and we will get y is greater than 5. If you are one of those and you must have the variable on the left-hand side, that's fine. We can write it like this. Y is greater than -5. Just make sure you have the signs correct. -5 gets an open circle, ladies and gentlemen, when we have to graph on a number line. If it doesn't have the equal sign underneath the inequality symbol, it gets an open circle. And because we are greater than, we're going to go out towards infinity. Okay, every number bigger than -5 is part of this solution. All right. Example number 2. Solve 12 greater than or equal to -0.3 times p. So we will divide by -0.3. -0.3. And remember, guys, when we divide, we will change the direction of the equal sign. Okay. Let's see, 12 divided by 0.3, we know it'll be negative. Let's see, be 40, I believe. You can use a calculator to check. Yep. All right, so -40, not on my number line, so you can draw your own. That goes from -10 to +10. At some point, if you could just have a 0, so we have a frame of reference, -40 is somewhere over here. Closed circle because of the equal sign, okay? And p is greater than or equal to, so we will draw our arrow that way. And if we were to write this in interval notation, right? In interval notation, how could we write this? Because p is greater than -40, we will include -40 with a bracket, and because we are greater than, we are going towards positive infinity. All right. Here we go. Let's see. Example number 3, I believe. We're solving for x. We have 2 of them. One on the right side, one on the left. So let's try and figure out how we can get them all on the same side. Let's get rid of the fraction by multiplying 2 both sides. Multiplying +2 doesn't change the inequality symbol. So it stays greater than. Alright. We could subtract x both sides. And we get something like this. -3x greater than -7. And we'll divide both sides by -3. And we see our final result. Because we divided by negative, we will flip and make it less than +7/3. In interval notation, x is less than 7/3. So what that means is we are going towards -infinity, right? So this is where we're coming from, left to right, -infinity. We will stop at 7/3 and put a parenthesis around it. No equal sign, so it gets a parenthesis. So 7/3 is what? Approximately, it is 2.2 1/3. So we could say somewhere right here, we'll put an open circle, and less than means we'll go off towards the negative direction on the number line. Okay, application problems. you should have a couple in your homework. Jared has at most $15 to spend today. He doesn't have a penny more, right? He buys a bag of pretzels and a bottle of juice for $1.59. If gas at the store costs $2.89 per gallon, how many gallons of gasoline to the nearest tenth of a gallon can Jared buy for his car? So here we go. We have $15 maximum. Let's use a different font. $15 maximum. He buys a bag of chips, pretzels, and a bottle of juice for $1.59. And he's trying to get the rest of his money. He's going to use it for gas, and it's $2.89 per gallon. We don't know how many gallons he can afford. So that expression represents $2.89 per X gallons, plus the chips he already bought, the pretzels and juice. So he's got his $1.59, okay, at most, less than or equal to 15. So here's the two-step inequality that we can be able to solve. So let's take $1.59 and we will subtract it from 15. So 15 minus $1.59, okay, which is $13.41. And we divide both sides by 2.89, and it gives us approximately 4.6. So he can get approximately 4.6 gallons of gas. Now notice the less than or equal to, he doesn't have to get 4.6 gallons. I'm just saying if he wants to spend the rest of his money on gas, that's how much he can get. And now in the context of this problem, we could theoretically write this in interval notation. So x less than or equal to 4.6, you would say negative infinity, comma, 4.6, and bracket. But, like I said, because we're talking about gallons of gas, the least he could get would be 0, right? He can get 0 gallons of gas all the way up to 4.6. So that is what I would look for in the application problem, where he can go from 0 to 4.6 in interval notation. I think that does it, guys. Go ahead and attempt the homework now. If you have questions, email me. If not, we will reconvene on Monday. Go over your quizzes and make corrections over the weekend. Come back Monday and we'll talk about that as well.